Okay, so everybody should be able to see my presentation. Thanks for joining us. Obviously, the introduction went through pretty well. This is not me. As you can see in my video, I have a little bit more hair. So let me tell you a little bit about myself. I'm Brian. I'm a managing architect at Concurrency. If for those of you who know who Concurrency is, what that kind of means is it's a fancy little title, which means I still get to do a bunch of building applications, which is cool. And I get the privilege of being able to manage, mentor, and lead, some of the members of the team. But I still stay pretty hands-on. In terms of the talk, I wanted to kind of level set. I like the fact that Kevin threw out there, please make this interactive. I would prefer to be interrupted. Maybe raise your hand using Teams if you want, but feel free to interject. I also have a tendency to talk fast and not pause. So feel free to tell me to shut up and let it all sink in for a minute while I continue. So I intended this to be more of a 100 level course in terms of Azure Functions. I'm going to go across the wide breadth of information and not go terribly deep into it, but I want to make this kind of interactive. So I've got some stuff built up. We'll go into the Azure portal, we'll play around with some toys, and we'll just see how some of the stuff works as well. So from from an agenda standpoint, I'm just going to kind of go over some of the use, how this stuff works, talk a little bit about some of the management of it, how you can get it out into the Azure portal, and then give you a couple of things to think about in terms of figuring out what went wrong, because we're developers and things go wrong. So why am I going to use Azure Functions? I guess that's kind of like the first thing. So let's talk about what they are. They're serverless compute. And so, I had a conversation with one of my coworkers the other day, and we were talking about some, basically some command line Java thing that he wanted to run. And we're like, well, what should we do with this thing? And ultimately, we kind of landed in putting it into an Azure function for a lot of reasons. So, you don't have command line access to tools in Azure, generally speaking. And so Azure functions are a way to kind of throw a little bit of code up there to do a single purpose. So how would you get started with this? You can use Visual Studio Code or Visual Studio. I'm just an old school dude that doesn't really like new tools. So code isn't really my preference, but I was playing around with it in preparation for this, and it had some really slick interfaces. If you remind me, maybe when we go through some of the actual walkthroughs, I'll show you. We can open up in both, but it was actually a pretty nice experience to work in code once you had the extensions installed. With Visual Studio, mostly when you're installing the Azure tool set, you'll get the functions out of box. So you really don't have to install anything extra in terms of to get this up and running. So what can you do with it? These are the officially supported languages that you can use, the frameworks that you can use. So it's a pretty diverse skill set, but at the end of the day, it's more or less a web service. So, if you feel like putting a little bit of extra effort into it, you can get a lot of other frameworks to work with it. I'm a C# guy. If you want to talk about any of these others, we'll have to wait for a different day. Another thing to consider is that there are different runtime versions. We're currently at version 3, which has a lot more support. Versions 1 and 2 were pretty limited, and if you're going to be doing any kind of new development, my guess is you're probably just going to go with the 3. So I'm going to pause since I think I've done 4 slides, maybe 5. Anybody have any questions, thoughts? The core of an Azure function is a trigger mechanism, and it's basically a decoration to your main method, if you will. You can have multiple functions within a project, so it's not exactly like a main method, but at the end of the day, you're creating a single trigger. These are the different types of triggers that that are supported. So there's a lot of different things you can connect to out of the box, and then you can also create custom triggers too, which I started to go a little bit deep into that, but at the end of the day, I didn't want to spend a lot of time going into custom triggers. It's pretty complex. I put green check marks next to the different triggers that I've used personally. So I've done quite a bit with them, and but not done every single one of them. Anybody? The Dapper and Kafka ones. They had some. They will only work with containers in Azure Functions. So they have kind of a difficult setup in terms of getting them to run, but they are supported. And then the image here that you see, and we'll do this in the walkthrough in just a minute here, is that these are when you go and set up a new Azure project in Visual Studio, this is the list of the triggers that you get. Are any of these not clear? Would you like me to go through each one of them and sort of talk what they are, or how you would connect to them?
Maybe another quick note about the trigger. I think relatively easily you could also tie it into a logic app, which kind of opens up a whole nother series of triggers as well. So, if this doesn't suit your fancy, there's, a simple logic app could expand your triggers tenfold.
Good point. Excellent point.
Is the Twilio one based off of like a text message?
I haven't used it. I would imagine that it's probably some sort of a API key that you connect to and have it trigger some sort of message from Twilio. Could be. Okay. Oh, I was going to do a little bit of a walkthrough. One thing, one of the things that I put this slide up here for was just to note I found this extension, the Azure Functions extension, is extremely helpful. There's a lot of things that that you'll need to do, things like settings or IOC. It just has a lot of helpful tools in here where if you do install it, you're going to want it. The screenshots that you have here actually from the experience with Visual Studio Code, but what I wanted to bring up was Visual Studio. And so here I have a couple of projects we can kind of walk through and take a look at some of the specific triggers. But in terms of getting started, it's literally file new, and one of the project types is Azure Function here. So if we create an Azure Function, I don't believe that Twilio will be one of the ones that we can use, but anybody have any particular, let's do a poll or first one to call out. What type of trigger would you like to see? Blob storage, fantastic. Okay. And we skipped pointing it at a blob container. But essentially, you have a connection string here, which tells you what blob storage container to connect to, and then you're going to be watching a container for some change events. I don't have a sample that I set up to have working for this particular one, but I have used this in the past, and anytime that you would drop a file or change a file or do anything inside of the blob container, you basically get this trigger invoked, and then you can do something with it. And hey, Brian, I do have, yeah.
Brian, can I get you to zoom in one click or so just to make that just a tad more readable? Nice. Thank you.
You can do 20 clicks.
Thank you.
I'm an overachiever. So I'll just point this out too. They have kind of this default logger, and when we get into kind of the troubleshooting in a little bit later into the talk, but anytime that you log out, you can kind of see these system traces. What I like to do is instead of using the out of the box iLogger, I'll use App Insights or something like that inside of the application to do a little bit more robust logging and keep everything kind of tied together. So before I get any further into some code samples, because I do have some code samples that we'll walk through and take a look at, I wanted to talk about some other different concepts, in terms of getting the Azure Functions up and running. So there's this concept of durable functions, which is essentially, longer types of processing activities, different patterns that you would go through in order to chain events. So you have orchestrator functions, activity functions, entity, and client functions. And so these are all basically different types of functions that work together. And the way that you would see these are these different patterns that you run into. And I have a couple of examples here to show, but you can chain functions together where you do one operation, one then the other. There's fan in, fan out, monitoring applications, which would, be a good use case for like monitoring applications would be if you had a long running process and you wanted to perform status messages. So you could kick off an HTTP trigger, an HTTP event, which would be your long running process, and then pull the monitoring function to figure out how far along it was in the process. So where we've used this in the past is, as an example, would be we had a antivirus scanner that would run on a file, and we could get messages back from the antivirus scanner and report back to the user. And we knew it might take, 10 or 15 or 30 seconds for it to run. Async HTTP APIs is another good example. Type user interaction types of things, so maybe call center type of things, and then aggregator functions. So I wanted to walk through a couple of examples that we've done here at Concurrency, and this is basically your traditional chaining of events. So we were watching a blob container, and when we saw a file drop, we would load the records that we found into a Cosmos database. We would set up another function trigger to watch Cosmos for record changes, and when those record changes would happen, we'd do something with them, something useful, and then that useful information would get put into an event hub. We'd pick up the message from the queue and might do something with it and store that information into a SQL database. And then at some other point, we have another alerting function that looked for something to complete, some action in SQL, and then it would send out an email alert through SendGrid. And these are all functions that were linked together in this orchestration module, so that you could see the events, tied together in your App Insights or when you were monitoring the functions. Another example might be this fan in or fan out type of approach. So in this particular case, I was working on some sort of like data warehousing, and I had to grab all this data from an API where you'd be paging through tens or thousands or tens of thousands of records or hundreds of thousands of records. So I might need to make 150 or 250 HTTP requests to get all that data, but none of that data was really dependent on each other and didn't have to be aggregated before I did anything with it. So what I wound up doing was just figuring out how many pages I needed and then fanning those out to different functions based on not only the entity type I was trying to query, but also the number of pages and whatnot. So those are a couple examples. Any questions about those? I can go back and show the other example too. Any possible concerns you might want to know about? So for us, why did I break these apart? Would be a first question I would have. So with previous version, the version 3 runtime doesn't have as many problems in terms of long running operations, but in runtime 1 and runtime 2, there were some significant limitations in terms of how long a function could run. And when we get to a little bit around the performance, I think I have a slide that kind of talks about it. If not, version 1 runtime had a kind of a hard limit around 10 minutes of an operation running. Runtime 2 has a limitation of, generally speaking, 30 minutes of runtime, unless you go to one of the elevated plans. and generally speaking, version 3 doesn't have a lot of restrictions in terms of long-running operations. And what you'll see when you have a function that times out is it essentially stops running. It'll throw an error in the error message, and the process essentially restarts. The app service restarts.
A quick question: what would
Yeah.
be a real use case for this? With the diagram which you are showing here, it starts from an event hub. Sorry, it's a blob, right? And then goes to Cosmos, Event Hub, SQL.
Yeah. So part of it has to do with so each one. I got to be careful here. Client specific stuff, right? So this is work that we did for clients. So the blob storage was a set of data that was being collected. It was basically web scraped data that was provided by a third party, and they had no real understanding of the system we were building, so they would drop a JSON file into the storage container for us. So we needed some mechanism to be able to just react to that file drop when it happened. We would take those records and we write them out to Cosmos DB, and we're looking at probably each one of those files having somewhere around 50,000 records in them. So processing that in Cosmos DB can be quick, but doing all the other data processing around it isn't necessarily as fast, to do. So writing it to Cosmos was super quick. Do that all in one operation. Read the data in, write it to Cosmos, and then each one of the writes in Cosmos would fire off a trigger where we could actually do some analytics on it. What do I want to do with this data that's being ingested? From there, we wanted to communicate this to a different data set. So we had some other work in a different system we wanted to do, and so we used basically a queue to do that, to send those messages to another system, and we did that for resiliency. And then the SQL job, essentially, the SQL data, it was essentially waiting for a trigger to happen. It wasn't on every record that was happening, but we were waiting for all of the work to basically be completed for the processing of the file, and then we would send off an email.
Cool, that's helpful.
Yeah. Good question. Any other thoughts? Or anybody want to go back to a different one?
That particular example sounds to me like some things that we've done where I work, where instead the data factory was actually a better fit for what we were doing.
Could be. As with everything in Azure, there's many ways to skin the cat, right?
Right.
I think that Data Factory could potentially be a good fit for that.
Are you going to be getting into it all, the kind of the layout of how something a little more complex like this? What is the ideal way to set up your solution and the layout of the function apps themselves? And if not, that's all right too.
Yeah. So I'm trying to think here in terms of complexity, what I want to walk through. I could show you some of the internal projects that I've walked through or that I've done. So like this secondary one, I could show you kind of like what that code looks like, because it's kind of like an internal application. Sure. Where it just pulls some Maven Link stuff. But what's interesting about that is that if you look at that code example versus like the out of the box Hello World stuff that I have prepared for this, gets a little bit more into like how you would set up like IOC and some of the more like some of the other stuff there, right? Okay. So I was going to transition to showing code, and kind of showing like kind of a functioning ecosystem here of things talking to each other. So I basically have two different function apps. These could easily be contained in the same project, but in terms of maybe you have some different systems and they're not controlled by the same group of people or whatnot. You just might have them separated. So in the first one, I created some HTTP triggers, and when you create the hello world in the HTTP triggers, you have 3 different ways that you kind of secure them. One is an anonymous function. Another is authorization function, which basically means that you're going to go get a key when you interact with it in Azure's portal. And then the last one would be like kind of like this admin. It's a little bit similar but more elevated in terms of usage. So with each of these functions, though, basically the default behavior is it just grabs a query parameter called name and gives you an HTTP response. In this case, it'll say something like, "Hello, your function, executed successfully." So so we can start with this and just hit F5 to run this, and I'll bring that up on the screen. You're going to get a console app. And you'll get something like this with every one of the applications. You're going to see this. Wait, I have the wrong app started. So let me set the correct startup app. And you get to see the punchline already if you saw the red message. But here's my console app. You're going to see that I've got 3 functions that are running. I have 3 functions that are actually executing right now, and they're all HTTP triggers. The blob trigger is just an artifact of me doing some deployment stuff. But these are the URLs. I could directly click on these in a browser and get a response. I could use something like Insomnia to get a response. Well, the HTTP admin should probably, let me grab Insomnia really quick to show the response. Let's see. Let's get the right URL in here. And so I just added a Milwaukee Azure, and this is the response. You get it in the HTTP response. Since I'm running locally, the authorization is not as, like, you don't need the token, and so you'll get good responses from it. But just like anything else, if I type something wrong, I'll get a 404 response, not found. So, but the nice part is that you can see, all your trace messages coming through, the command line. And you can see exactly what happens to be going on. If you have a timer trigger, what you saw before was, some of the events that were happening within the application that were logging to iLogger, and that's essentially where these messages are coming from. So now to take a look at something that's maybe a little bit more complex and a little bit more enterprise worthy, I think that's what the question is. The question would be like, how do I build like an enterprise application with this stuff? Well, before I go on to that one, let's take a look at what I did here in this project. So I have my HTTP requests firing off, and then I also created a Azure Timer function. And this particular function I have running every 5 minutes, every minute divisible by 5, essentially. So with timers, you use a cron notation. If anybody's not familiar with it, I'm not a Unix guy, or Linux guy, so I'm not super familiar with cron formats. So every time I have to set something, I wind up going to the documentation to figure it out.
It is well documented.
It is very well documented. They use it all over the place. So here are my 3 URLs that are out in Azure, and all I'm really doing is making a single request to each one of them every 5 minutes. So if I switch over to this function app and run this, you'll see the messages traced through here. You see one of them that throws an error. I actually do hit a error condition in this with the admin function because I intentionally wanted to have errors show up. So it can actually hit that endpoint and it returns an unauthorized error code, and I log that to the stream. So this is kind of an example. I know it's very trivial, but it's, I have two function apps that are sort of working together hand in hand. So let's take a look at, something else. I sort of talked about this in terms of this being some information, this pulling information out of a, out of a report, out of a system, or just grabbing data entities out of something. So in this particular case, I wanted something that was going to, support IOC containers and also using application insights to do some of my logging as well. So, here I have a much more traditional layout in terms of creating services and having testable code, if you will, right? So the more important part here would be one of the functions inside the startup. I believe it would be startup. You're doing things where you're building up your how am I going to get my configuration settings? How am I going to use some of those configuration settings? And then how do I tie this up to my IOC container? And then almost all of this comes from the Microsoft extensions library. So if you think about what I had mentioned before, that you're really going to like that, that's where the dependency injection and the configuration stuff comes from. But it doesn't have, so function apps themselves don't really have, like when you start up a project, a default app settings file or a default config file. You sort of have to manufacture that yourself. Great question around that. Does that answer your question? I think, was that Kevin that asked, or somebody else?
It does, yeah. It's a lot. I was very, very curious, like where you want to make the delineation between the simple function there and how much logic you might put into a domain class behind it. And it's a normal app, and the app run is that surface area in the function app itself.
Here's essentially what I'm doing, right? I mean, I could literally drop this down to one here. In fact, actually, the guys on my team is going to move this code out into a different function, since it's, why have a one-time thing? Just make a one-time function that never gets run. So, things like that. But it should be very simple. It should use like kind of a service, based architecture. You should use best practices when you're doing this in the real world. There are some limitations, like I said, with the iLogger. I'm not super satisfied with the way that, I like to have like this end-to-end story within App Insights. And when you do this correctly, you'll get that end-to-end story. I'll kind of hold off on that because, it's going to go really quick in terms of me getting to that. But cool. Anybody have any other questions? Want to see anything different around that? Keep them coming. Okay, so ask your coworker. They're better suited. They're certainly usually better suited than I am. But okay, so let's talk about some of the, I guess, for more of the infrastructure, types. How do I get this stuff out there? So for deployment and resource management, certainly, if you're using ARM templates or Terraform, you can certainly do that. And they are supported in both those, obviously, ARM for sure, Terraform definitely. And then in terms of using Azure DevOps, or if you're using GitHub Actions or whatever flavor you want to use in terms of deployments, there are pretty much out of the box, at least in Azure DevOps, where I'm familiar with it. It deploys pretty much like just a regular app service. So it's fairly trivial to get that deployed. In terms of Visual Studio, there's a couple different ways you can deploy it. Basically, publishing your application directly from Visual Studio, you can get a publish profile from the portal and publish it that way, or you can create your own sort of on the fly here, and then it's more or less kind of a just a one-click publish this to the web. So when I did this a little bit earlier today, what I wound up doing was configuring where do I want to have this point to. One thing that I do want to note, where I'm getting to where this part is, I would touch this in this pricing, but Azure Functions essentially are a super pared down app service. And so one of the things that it requires is it requires an Azure storage account to run. So you must have a storage account. You can't just deploy like one single app function and think that it's going to run. You have to have a storage account to it as well. So so there's that. Now within the Azure portal, they've got some pretty cool tools that you can use. I haven't played with them ever because I'm a programmer and not a WYSIWYG developer. No offense to any WYSIWYG developers, but there is some design time support out there. Again, I haven't played with it, but it's also in preview a little bit. So the next thing I want to talk a little bit about was, scaling and how scaling works. So with Azure Functions, one of the nice parts, one of the reasons why you would use this, and one of the reasons why, if you go back to my earlier diagrams, is that when events happen, I can respond to all those events at the same time. It's not a single application that's running. So in the case of 50,000 records that are being updated in a Cosmos DB, I essentially am instantly responding to each one of those record events as they happen. Not in a multi-threaded application, but literally in separate app services that are spun up. So what winds up happening behind the scenes is that it just creates a new instance of your function host, and it replicates really quickly so you can respond to those events. Startup times are pretty quick. Generally, in the current runtime version, they've done a really good job of getting the startup times, in terms of the infrastructure aspect of it, to maybe 2 or 3 seconds to get the app up and running and functioning in Azure. So cold starts are, you might want to do it in terms of if that's really important to you, but I would probably ask yourself first, if you need to do a cold start, why do you need a cold start? And if you do need it, is a function app actually the right tool for you to use? So there's 3 general ways that you can do this, and I'll talk about the second one on the next slide in a little bit more detail. But the first one is kind of what a lot of hack, use hack, because I've done it too, is just set a timer. Have inside of your project have a warm-up timer that runs every 20 minutes or so. 20 minutes is about the lifespan of an idle app. Function app. So if you set a timer to run every 20 minutes, you can pretty much be sure that anytime that you need an application, your first instance of the function host will already be warm for you. Another way to do this is to upgrade from the consumption plan to the premium plan or the dedicated plan. Or the last way is to just have a dedicated app service plan for it. Which was redundant, whatever what I just said. So here are the 3 different types of hosting plans that you can use. I alluded to the first one was consumption, and this is kind of your default, and it's really nice because it's cheap. It's the cheapest one of the 3, and you literally only pay for there's the calculator. You'll pay for events, each independent event that happens. You pay by bandwidth. And by memory, I believe by executions as well. So you're only paying when the functions are running, and then you get these, great scaling events to happen as well. And if you need a little bit more performance, or you need to react a little bit, or if your functions are longer running, then you'll want to go to the premium plan. You'd be able to support extended execution times, which in a lot of cases are unlimited. at this point, but they, generally speaking, at over 10 minutes is, you'll definitely want to go to the premium plan over 10 minutes. And then you have some additional feature sets, such as like the virtual network connectivity or some other like, specific things. If that's not enough, you can go to a dedicated app service plan. Essentially, is what you wind up doing. And the recommendation here would be, I already have this website that doesn't do a tremendous amount, and it isn't being utilized, but I can't really go any lower, or my system will start to perform poorly. So you could share that with your Azure, with your Function app, and that you kind of share that cost across a couple of different systems. Then the other bigger reason you might do this, if you had some sort of a custom image that you wanted to run, you would be another good use case, that you wanted to run something that wasn't supported in the traditional consumption or premium plans. In terms of cost, I didn't put like dollar amount pricing in here. I do have on the next slide a link to somebody that did some really good study, just a really good job at comparing performance and pricing across different different clouds. So I'll go ahead and see that, but we'll bring that up really quick. But here's a side-by-side comparison of the performance and throughput between the different clouds. So at the best performance is Lambda, and from what I can really say is that Lambda, I think the biggest difference between the other two systems is more or less that it really is a one-to-one. You're getting a dedicated resource with AWS instead of like a shared hosted thing. So they're probably always going to run better unless the other two clouds decide to support that same model where it's dedicated resource, for those services. But over the last, this was run, this performance assessment was essentially run after the Runtime 3 came out, and you can see that Google is yellow and then Azure Functions are blue. They start to perform, they start to get into a little bit more parity with the other two, and so there used to be sort of a dig in Azure Functions. They didn't perform quite as well, but that doesn't really seem to be the case anymore. So pricing wise, another reason somebody said why use Azure Functions, if you have the right subscription set up, it can be free. So free grant covers, I don't know what the exact metrics are. I was going to include this, but I ran out of time. It's 400 gigabytes of execution time or something goofy, right? It's there's a certain amount to it. It's pretty significant. I want to say it's something like 4 million executions within a month and a specific amount of data transfer that's included. So in some generally light loads, it literally could be free. In terms of client pricing, I'm not always privy to some of these more sophisticated high throughput to give you some general like guidelines on that. But the gentleman that did this testing over here, he put together for a pricing comparison between the different consumption plans. He put together basically an HTTP webhook that would do something like 5 million calls a week or a month or something like that, and he was paying somewhere around $75 a month for the consumption plan, $150 for the premium, and just a hair more, maybe $175 for the dedicated plans. But the dedicated plans would literally be, you're paying that app service, you're paying that tier, so if you want to do, S1 or, whichever plan, it would just be that cost, and you're running within the app service plan. Anybody have any questions around pricing, performance, or the consumption plans, or how scaling works? Any of these topics? Okay, so I promised that many things will go wrong because you wrote this code. And so I wrote this code, so many things do go wrong. And what I wanted to start with is taking a look at, where would I go figure this out? How do I figure out what happened? So as we had up on the screen just a little while ago, I wanted to bring up in the Azure portal just a little bit of a walkthrough where you would find some stuff here. So in terms of App Insights, I did want to kind of show you this like end-to-end sort of, transaction, how things were going through the system. So let's see if we can drill into some of these examples and see the end-to-end, how this all works when you're tying things together. So you can see at the top, I have a Azure Function instance that did something. From there, I'm getting everything linked up nice and perfect, and see that Azure function actually made 3 different calls to a couple of different Azure functions, the HTTP ones. I can see which one failed. I can see what the reason code was for it, and if I had more activity within this Azure function, I could probably I could see exactly what else would happen here. Because this is all tied together with App Insights, I get all the other telemetry, type of information. I can see, what my server response times were. I can look at historical things and do my traditional troubleshooting there as well. I don't have any actual failed events happening because I'm getting a 401 response. The function app itself isn't returning, a 500 request or something like that. Now to take a look at the function in terms of logging, there is, we can migrate to that fairly easily, but I wanted to bring that up since this is real time, is showing exactly the events that are happening. And if you remember, I only have this running every 5 minutes. I didn't want to wait for 5 minutes to show you what happens in the log. But let's go back to how I have this laid out. We would go to, see, this was our timer function that we were taking a look at. From here, you can look at what functions are registered here and dive quickly into each one of the functions and get some basic telemetry here. And then to get to the monitoring tools, which is where I was at before, there's a couple of really neat ways to take a look at it. Each one of these invocations is logged. So if I had a HTTP request or any other event, it would, under each of the functions, it's whatever invoked it. You can see that I have this operation ID, and if we go back to the other bit of code that I had here, you can see that for my logger, I'm actually grabbing my operation ID and setting that so that I can tie everything together using App Insights as well. So especially when you're chaining, start to chain things together. So inside of this view, you can start to see each one of those messages sort of packaged up nicely. And then to get to the stream that we looked at before, it was the log tab essentially here. These are the invocations, and then here's the log. Now again, this is just going to wait. Well, I guess we hit the timing just right. So this is all you're literally looking at a stream of messages that are coming through. So one other thing I wanted to kind of show, you also can interact with these functions in meaningful ways in terms of setting up your other ones. If you, so I had these URLs that I wanted to call these HTTP triggers. So this function app has my three applications, and for ones that have the authorization level in particular, you need to come to the Azure function and actually generate a function URL, and that'll have a hash code for you, authorization code for you to use. So your URL is actually a little bit longer than just the basic route. And then for each of the different function types that you might have, there are other ways, there are other supported things that you might need to do here. So again, at this view, I just wanted to show I've got a couple of functions, a couple of function apps, I should say. They can contain many functions, but these, I basically had these two. The playground was, something in case we wanted to play around today. But you have your two function apps, and you need to have your two storage accounts as well. Anybody want to see anything more here? So we could take a look at the cost analysis. What does it run up today? Yeah, not enough time. And I have not been watching the chat if anybody has raised hands. Okay, so let's go back to PowerPoint. I did some looking at the App Insights questions. If I don't know, I'll ask her. I hope she's available.
Brian, there was a sort of a question that might have been kind of joking earlier, but the question was,
biceps?
no, that one, I think the point there was more you could use it to deploy if you wanted to.
Sure.
About using Dart as a language, which you might not really want to do with an Azure function, but you mentioned, if it wasn't one of the supported platforms, you could indeed use Azure Functions. What would you have to do if you said, all right, I want to use Dart in an Azure function? What do I have to do to get my framework and everything else up and running there?
So give me what is Dart? I'm not familiar with it. So somebody educate me, and maybe I'll be able to give you an answer.
I think it's some Google language that I think you could use for a lot of different things, but I don't know.
So in terms of running the language or whatnot, it's a client optimized language for fast apps on any platform. So probably you would need to install so let's take a look at. Let me answer this in a slightly different way.
Or what if you said, maybe not language independent, what would you, React or Go or something, whatever, pick your choice of whatever you might want to do. It doesn't necessarily need to be Dart.
Well, React, you're essentially talking TypeScript then, and that's sort of out of the box.
Okay.
Right. So in that sense, I think it would be, okay, so Dart compiles to a native code. So, all right, so I wanted to go to the function app itself. And I think a good way to explain this, good way to kind of illustrate what this really is behind the scenes is that, your blades are very similar to, any other app service, right? So I can go and take a look at what actually got deployed here. And then one of the files inside of here is, can't remember what the JSON file is, kind of tells the runtime what it needs to do in order to run. That's essentially all it really is. Maybe as that's loading. It's this host.json file. And so in terms of doing some sort of a custom, that's really interesting. It's the same file that's in Visual Studio, so that might be the fastest way for me to get to it. No, that really won't. Essentially, within the host JSON file, you specify, what runtime DLL you need to execute for this. And at the end of the day, the way that these things are kind of interacted with, they're the same way that an app, a web app would respond. So I believe, that's kind of how you would, if you're going to create some sort of custom, function. That's when I was looking at it, that's what you would need to do is sort of have a HTTP request handler in whatever language you want. somebody is, this is always dangerous. I randomly clicked on somebody's link. Terrible idea. Especially with a link going to Twitter. That was a really, really bold move on my part, or a very thoughtless one. Yeah, so, but essentially, here you go. Thanks, Cameron. Boom. So here's this is essentially where a lot of the settings are here, and I think one of the things that you get here is a startup, some way of specifying. Like I remember seeing a DLL specified in one of the apps that I loaded someplace. So maybe there we go. Boom. Function.json. So essentially, you know, this compiled down to a DLL, and this is where it's pointing itself at. And then I believe also, so if you created, create a custom language, create a custom binding, so you could have some sort of trigger that triggers off of, I don't know, pick some sort of event that might happen in the real world, you know, that would call back into this. You could create a custom binding, which, you know, I started to play around a little bit over the weekend to see if that'd be an interesting thing to add here. And then, but I didn't go that way. Now, when you set up a function, one of the things that you have to decide is not only the, you know, I created these before we got here, so let's just go ahead and add another function. You create your, you have to decide what your runtime stack is going to be, as well as how you want to have this thing hosted. So, you know, someplace in here is where you sort of figure out if you want to do what kind of hosting you want: Linux, Windows, .NET, whatnot. Here you go, operating system type. So presumably, if you had, you know, some other, and then you can also build, you can also have a container host, but that, if you want to have a custom container for your host, then you have to go to a dedicated plan. That was kind of that, you know, before. So in that sense, if you really wanted to do something completely out of the box, like with Dart, and somebody actually found a blog post about Azure Functions in Dart. One of the ways that you know, off the top of my head, you might have to do that is just create a container for the host, and then be able to execute what you want. And the functions JSON is essentially the instructions and how you tie it all together. Adam, I believe, yep, I believe the answer is yes. At some level, you can make it work.
All right, thanks for going down that rabbit hole.
No, it's cool. I mean, I at least read about it before I came here. I didn't come completely ill prepared. Any other questions? Any other thoughts? Discussion? So that's the end of my presentation, I think.
All right, I'll
no, ask questions.
What if you were taking a look at, you know, choosing where you're going to host something, you know, some logic out in Azure, what would be a scenario that you don't think would be a good fit for running in a function app?
I had somebody ask me if they could run a essentially have a microservice, you know, like an API, you know, running. And, you know, one thing to remember is that, you know, these aren't really stateful applications. They take one execution and they run from scratch. So from that standpoint, it might not be the most performant way for you to serve up information. And when we think about REST APIs, you're thinking about doing something interesting with something that you have to attain and get. And if you had an app service that had to, connect to a SQL database every time that it, you're not really sharing things. It's literally running in separate processes, separate VMs, if you will, in potentially different servers. So, but if it was, fully autonomous and it was, randomly serving up pictures of cats and you had a, and you're using Redis cache to pull it from, maybe that would be okay, right? So there are some ways that that it would be appropriate, but I would think about it in terms of understanding what the architecture is in terms of how it scales, to sort of think about that process of, do I want to invest that into it? Now, I do say that saying, all of these things, these use cases that I talked about, they do they do connect to SQL databases, and they do perform interesting things. But why you would want to use it is because of the scaling aspect of it and be able to do that multi-threaded processing. So I can process, if you think about a traditional application where, I might have to create multiple threads to process 50,000 Cosmos DB records at a time. I can do that, I can do that with, massive scale, and 50,000 isn't even like a limit, right? So theoretically, there is a limit to how many instances your host can scale out to. I have only ran into it once, and it is a internal Microsoft setting where you basically have to call the cloud team and have them like turn the throttle off. They don't really care because you're paying for the consumption, but they put it as a safety mechanism in case people are doing something weird.
Got it. And please don't steal my idea of randomly serving up images of cats.
I think there's a site out there for that.
It probably is.
No, I know there is.
Running on Azure Functions?
It could be. I don't know. Lambda does, perform a little bit better. So if they're serving up a lot of images, cats are in high demand. So, okay. Any other questions? Cat as a service. I'm tempted to pronounce that the wrong way. So I'll keep my mouth shut. There's another one that I used to use. I don't know what it was. When I was at SafeNet, Trey, he had all sorts of image repositories he would pull from that were interesting, not always cats.
Sure, yeah.
Sometimes dogs too.
Sometimes dogs. Yeah. Nothing inappropriate. So I don't really have anything else to present on. If anybody wants to reach out to me, here's my work and personal email. I don't really do any social media other than LinkedIn. I know I'm a boring person, but I'm happier that way.